Hello everyone, welcome to a new session of your mathematics class. This is our fifth part of our chapter number 2, Polynomials, and it would be our last session in this particular chapter. Now, in this session, we are going to learn the algebraic identities. So far in this chapter, we have learned what are polynomials, how can we factorize polynomials, and we have learned two important theorems, namely factor theorem and remainder theorem. Now, in this session, we will learn 8 algebraic identities and we will try to solve or we will try to factorize the given polynomials based on the algebraic expression that we are going to learn. So, first of all, let's see what is an algebraic expression. Algebraic identity. Algebraic identities are simply some algebraic statements or expressions that is true for all the variables occurring in it. For example, in our lower classes, we have learned an identity called a plus b the whole square or x plus y the whole square. That is included as the first identity. Similarly, there are 8 identities of this sort in this chapter or in this particular section. We will learn all 8 of them and one each examples and one problem in which we will factorize the given polynomials based on the identities that we have learned. So let's go into the first identity. Let's see the first identity that we are going to learn. First identity is the basic one, x plus y the whole square. That is sum of two numbers to the power or raised to the power as a whole. Then we can write, if it's given like this, x plus y whole square, something plus another one the whole square is first number square plus 2 times the first number and second number plus the second number whole square. This has got a simple proof. I will do it just once. It's not important, but it's better to understand it. This is x plus y into x plus y, right? X plus y whole square means x plus y into x plus y. So we can take x and multiply using the second bracket. So and second term is y, multiplying throughout the second bracket, you will get x into x as x square, xy plus xy is xy, y into x is same as xy, plus y into y is y square. So you can write x square plus 2 times xy plus y square. Here the proof is not important, I just want to make you understand how we got this one. So it's all about understanding this identity by heart. X plus y whole square is equal to x square plus 2xy plus y square. Let's see how this helps us in solving problems directly. If we have idea of what is x plus y whole square, rather than finding x plus y into x plus y, we can simply write it as first number square. Who is the first number here? It is x square. So it's x square plus 2 times first number into second number, that is 2 times, so an extra 2 will be here, 2 times the first number is x into second number plus square of the second number. Who is our second number here? First number is x, second number is 5, so second number square means 5 square. So we can write x square plus 2 into 5 is 10, of course there is an x over here, plus 5 square is 25. This is the expansion of x plus y the whole square. So we can understand that we can do x plus y whole square in this format. Now let's see how can we factorize using the identity that we have learned. That is just the opposite process of expansion. The process of expansion when it turns to the other side becomes the factorization method. So there is a shortcut. I will tell you the shortcut to solve this particular question. If it is given like this, this is the first number. So you should understand, if there is a square, two numbers whole square, and you can notice that 49a square means the square of, or whose whole square is 49a square, that intuition should be in your mind. We know 49 is the root or square of 7. So we can write it as 7, and a square is the square of 8. So we can effectively write this as 7a the whole square. Now keep it here. How can you write 25b square as something whole square? Can we write it as 5b the whole square? Yes. So the half job is done. Now if we get this as this 70ab as 2 into first number into second number. If we get this a success, then we can write this as something plus the other one, the whole square. So let's see whether we are getting the same. So what's the general form? First 2 into first number into second number. So let's try 2. We have put 2 here. What's the first number? 7a into, who is the second number? 5b. If we get this whole product as 70ab, then it's a success. Otherwise, we cannot proceed with this step. So let's try 2 into 5b, that is 10b. 10b into 7a. 10 into 7 is 70. A into b, 70ab. So we have got it. Now just see whose format is this one. First number square plus 2 into first number into second number plus second number whole square. Whose whole square it can be written as? This can be written as 7 plus 5b the whole square. Or we have been asked to factorize this one. So we can still further write 7a plus 5b into 7a plus 5b. So this is the factorized form of this particular expression. I hope you understood this one. This is one of your exercise questions. There are a lot of questions of this form. So I would recommend you to do this one to make it more clear. So let's move to the second identity. The second identity is just a difference of a negative symbol than the first one. It says x minus y the whole square is equal to x square minus 2 times xy plus y square. The same way that we did first number square minus 2 times the first number and second number plus second number whole square. Using this one, we can find the squares of numbers. Even using the first identities also we can solve, or we can find the value of 99 and 101 etc. So we are using this method to find the square of 99. So to apply x minus y whole square, I am going to rearrange this 99 as 100 minus 1. Then 99 whole square is effectively 100 minus 1 the whole square. Now what is a minus b? First number minus second number whole square. How can we write down first number square? So we can write first number square, that is 100 square minus 2 times the first number times second number plus the second number whole square. Then we can write what's the square of 10,000? Sorry, what's the square of 100? It is 10,000. So it's 10,000 minus 2 into 100 is 200 plus 1. Now we can easily write 10,000 minus 200 is 9,800. 9,800 plus 1 is 9,801. So in two steps we can find the squares of complex numbers or numbers of complex order. Now using this identity, let's try to factorize the given problem. We have seen how to factorize a given polynomial using the first identity. Now let's go for the second one. The idea is pretty same. First we need to make, if we find or if we are able to fetch a number to make it as something whole square, then it will be very good for us. So we will write 4y whole square as 2y the whole square. Any problem with that? 2 square is 4, y square is y square itself. Now there is a negative symbol, so I am putting that symbol like that only. Then what's the last number? 1. 1 is nothing but 1 square. Both of them are the same. Now we need to get of the form 2 times first number into second number, and we will try with that one. 2 times, who is the first number? 2y times the second number is 1. If we get this product as minus 4y, then we have succeeded. 2 into 2y is 4y, 4y into 1 is 1. So we have got minus 4y here, minus 4y here. So what have we got, or what can you write instead of this whole thing? Cannot be write as 2y minus 1 the whole square? Yes, this is no different. So we can write this is 2y minus 1 into 2y minus 1. So factorization is done. Let us see our third identity. Third identity says x square minus y square is equal to x plus y into x minus y. That is something square minus, or first number square minus second number square. It's effectively, or it can be effectively written as the sum of the first two numbers and the difference of the same. We will see an application. If we are asked to find the value of 12 square minus 8 square, the one who does not know the identity will do with the normal way. It's fine only, but when it comes to bigger number, it will be tough or difficult. So let's see in both the ways. First one is 12 square. 12 square is 144 minus 8 square is 64. We'll see that it is 80. So 80 is the answer that we should get even if we use this identity. Let's try to do the same. Now, according to the identity that we have learned, x square minus y square is equal to x plus y into x minus y. And the numbers are 12 square and 8 square. So it can be effectively written as 12 plus 8. Why? Because sum of the two numbers into difference of the two numbers, that is 12 minus 8. And what is 12 plus 8? It's clearly 20. Into 12 minus 8 is 4. And you know what is 20 into 4? That is 80. So effectively you got the answer that are not different. Now let's see how this helps us in factorization of polynomials. First of all, this is x square minus y square by 100. So if we are able to make this into something square, or first number square minus second number whole square, then we can factorize this as the sum of the two numbers times the difference of the two numbers. So let's try to do this one. X square, it cannot be written any further. Now y by 100, y square by 100 can be written as y by 10 the whole square. Is that okay? Now this is of the form a square minus b square. What is a square minus b square? Or x square minus y square? X square minus y square is x plus y into x minus y. So we can write this as x plus y by 10 into x minus y by 10. Hence we have done the factorization. That is the advantage of this particular identity. Let us see the fourth identity. Fourth identity says x plus a times x plus b can be written as x square plus x into a plus b plus ab. If you have any doubt in this or in any identity, it's very welcome to try and solve all the identities. I will try to solve this one. If you want, the question is to find the product of, or whether we can simplify this particular identity into a simpler form. For doing this one, we can write x from the first bracket multiply completely using the second bracket, that is x plus b, plus, this is the plus symbol, then a times the second bracket x plus b. Now what happens? X into x is x square plus x into b is bx plus a into x is ax plus a into b is ab. Now we can write further x square plus, there is an x common in both the terms, so I am taking this x times, who is the b plus a. B plus a or a plus b are the same, so a plus b plus ab. So we have proved the same. So whenever you see anywhere a number plus something times the same number plus a same or a different thing, then we can write it as x square plus, that is square of the first number plus first number times the sum of the two numbers plus the product of the two numbers. We will look for an example, then it will be more clear for you. For example, if you want to find the sum of 103 and the product of 103 and 107, you can further write this 103 as 100 plus 3 and this 107 as 100 plus 7. Now, is this not of the form x plus a into x plus b? Here the x term is 100. You can see both of in both the terms there is 100. Now instead of a and b we have got 3 and 7. So we can just apply this theorem that we have this identity that we have just learned now. And what is it? What does it says? X square. Who is the number x here? Is 100 square plus x into, that is 100 into sum of the two numbers, that is 3 and 7. 3 plus 7 plus the product of the two numbers, for the numbers 3 and 7. So this is effectively the product that we will get when we multiply 103 and 107. And what is 100 square? It's 10,000 plus this is 100 into 3 plus 7 is 10 plus 3 times 7 is 21. Now we can write 10,000 plus this is 1000. So 11,000 plus 21. So what is it? 11,021. So this is the advantage of this particular identity. Let's move on to the fifth identity. In this identity, you will see three different variables. Now, let's see how it can be done. We have learned how to find or how to write x plus y whole square in different way. Now we are going to learn x plus y plus z the whole square. If you are asked to find the square of three numbers being summed or added together, three different numbers added together or variables, then you can write x plus y plus z the whole square as x square, first number square plus second number square plus third number square plus 2 times first and second numbers product, then 2 times first and 2 times first and second numbers product, 2 times second and third plus 2 times first and third. That's just written here. If you need the proof, it's very easy. All you need to do is to multiply both of them together once. That is x plus y whole square means x plus y plus z into x plus y plus z. Now, just as we have been doing, take the first number. Who is that? It is x. The first number is x and multiply using the second bracket completely. That is x plus y plus z plus take the second number y and multiply in the second bracket completely plus take the third number z into x plus y plus z. Now just simplify, you will get the answer. So that is x square plus xy plus xz plus xy. I am writing in the alphabetic order so that let's not make any confusion. Y into y is y square plus y into z is yz plus x into z is xz plus z into y is yz plus z into z is z square. Now we will write the numbers with the variables with the highest power, that is x square plus y square plus z square. Then how many xy's are there? There is an xy, there is another xy, so 2 times xy in total plus then how many yz's are there? There is yz, there is another yz, so 2 times yz plus then 1 xz, another xz, so 2 times xz. So you don't necessarily need to by heart the proof, learn the proof. If you are confident to say this particular identity by heart, then no need to understand all the proof, but it's quite simple. Just try by yourself and you will be impressed by yourself. Now, questions can be asked for the examination of this sort, and there are lots of exercise questions in your textbook towards the end of your chapter. This is one of that question. I'm going to try to solve this one. So, on trying to solve this one, you need to be very careful with the symbols of the variables in between or the terms in between. That is, the first term is actually 3a, but the second number or the second term is minus 7b. Then only you will be able to reciprocate this identity truly. That is, this identity just says the sum of x and y and z. Similarly, this is nothing but 3a plus minus 7b. We will try to solve, then you will get more idea. So, what is the expansion of x plus y plus z? It is x square, first number square plus second number square plus third number square. So, we are going to follow the very same. I am going to write the expansion here. First number square. Who is the first number? That is 3a. I'll write down here. The first number is 3a. So, it's 3a the whole square plus y square. Who is y? It is minus 7b the whole square. And who is the third number? Minus c the whole square. So, no confusion is left. Now, the next term will be 2 times first number into second number. This first number is 3a times the second number is minus 7b. So, don't forget to put the symbols as well. Plus, the next set is 2 times the second number into third number. Second number is minus 7b times the third number is minus c. Plus, 2 times the first number and the last number. First number is 3a times the last number is minus c. This is the product, so I will put a negative symbol over here. Now just expand this one. 3a the whole square is 9a square plus minus 7b times minus 7b. The product of two negative numbers is a positive number. So I am not going to put the negative symbol, but 7 square is 49. So what can you write? 49b square plus minus c into minus c is c square. So do I need to mention that the two negative numbers are when multiplied will get positive number? No, you already know that one. Now comes the important part. 2 times. So let's try to multiply the numerical parts first. 2 times 3 is 6. 6 times 7 is 42. So 42, and there is a negative symbol, so we can write minus 42. Let's not forget the literals a and b. When multiplied together, it becomes ab. And the next number, 2 times 7 is 14, and there is a 1 over there because c means 1c, so it's 14. And what about the symbol? It is minus 7 here, and it's minus c or minus 1c over here. So when two negative numbers are multiplied, it gets positive. So I will write 14, and who are the literals b and c? 14bc. Now coming to the last term, 2 into 3 is 6. There is no term or coefficient for c. So 2 into 3 is 6, but there is a negative symbol. So let's not forget minus 6. What are the literals? 6ac. So this will be our answer. Yes. I hope you understood how it is written. Now let's see a problem for factorization also. So let's just read this one again.